Assalamualaikum, salam sejahtera. Today's lecture, I will give a lecture on copolymerization, which is our last topic for this semester. Copolymerization is a process to synthesis a polymer derived from two or more monomerid species. So copolymer is a polymer derived from two or more monomerid species. When a mixture of more than one or different monomerid sample is allowed to polymerize, so we will form a copolymer. I will give you a simple example. Okay, for example of the polymer, easy polymer, H nylon 66. So nylon 66 contain of hexamethylene and also monomer adipic acid. So when hexamethylene react with adipic acid, so it will produce nylon 66. So nylon 66 is a copolymer. Of copolymer is a homopolymer, which is the polymer that is made up of only one type of monomer unit. The other example of copolymer are polyethylene copropylene, polystyrene cobutadiene or SPR, polyvinylidene chloride covinyl chloride. So the classification of copolymer, we can see that it is classified into random copolymer, alternate, block, and also graph copolymer. And linear copolymer will lead to produce a random, alternate, and block copolymer. So linear copolymer can further be categorized into three forms. And this classification is based on the arrangement of the monomer on the main chain. As we all know, random copolymer have the monomer which is randomly placed on the chain, while alternating copolymer is monomer that contain alternate arrangement of the copolymer. For graph copolymer, contain a polymerid side chain which are attached to the main chain. We call it as a graph copolymer or branch copolymer. Copolymer contain two homopolymer block, while a tri-block copolymer contain three distinct block of homopolymer. One by one, okay, for this one is the structure of polyvinyl chloride, which is considered as homopolymer because it contains only one type of monomer unit, which is CH2CH. Attached to it is Cl structure. So this one is considered as a repeating unit. So we call it as the homopolymer because it derived from two or more. It derived from one monomer unit. Random copolymer. Okay, the placement of the random copolymer is containing more than two or equal to two monomer unit, which is randomly placed along the side of the side chain, main chain. Okay, now we look at the structure here. We have the repeating unit of the styrene and also the butadiene unit. So monomer 1 is placed in front of the main structure and followed by the butadiene unit, which is on the second unit of the monomer. So it will structure will keep propagate and repeating along the main chain randomly, okay, as illustrated in this figure. So the red monomer unit might be the styrene and the blue one is butadiene. No, sorry. The blue one is styrene and the red one is the butadiene. So this two monomer, call it as a copolymer, is randomly distributed along the main chain. For alternating copolymer, it contains a single main chain with the alternating monomer. The formula of an alternating copolymer made up of monomer A and B, we can generalize to A-B with the N unit of propagation. So nylon 66 or we have styrene maleic anhydride copolymer is an example of alternating copolymer. It consists For styrene, maleic anhydride, it consists of styrene unit and also the maleic anhydride. For nylon C6, it consists of hexamethylene diamine and also the adipic acid. Okay, now we proceed with the block copolymer. Copolymer happen when more than one homopolymer units they are linked together via the covalent bond. They will resulted in the single chain macromolecule. We call it as a block copolymer. So the intermediate unit at which the two homopolymer chain are linked, we call it as a junction block. So a diblock copolymer we contain two homopolymer block. Kalau ada tiga triblock copolymer, dia ada tiga distinct block of homopolymer. So in this structure we have a diblock copolymer, okay, because it contains two homopolymer block of styrene units and isoprene units. For graph copolymer, for it is branch copolymer. So it is a polymer in which the monomer it forms a branch structure. Some important types of branch copolymer include star, comb, grafted, and also brush copolymer. So for a graph copolymer, it is actually a branch copolymer featuring differently structured main chain and side chain are known as graph copolymer. So the illustration here shows the ethylene unit and acrylonitrile unit. The main chain or the side chain of this polymer can be copolymer or homopolymer. This one is the post-polymerization, how to make a graph copolymer. So basically, copolymer they can be synthesized from free radical polymerization. As we can see in the illustration, we have different types of monomer resulting in the form of the grafted copolymer, which is a dissolved polymer A in a solvent, and then we add monomer B and the initiator together, and then it will polymerize to form a grafted polymer by using a free radical polymerization process. Random copolymers, really random. So what is the importance of copolymer? That's why you learn this topic. An important polymer modification technique as you want to produce random, alternate or grafted polymer. It needs you to have a proper functionalities into the polymer. So by using the copolymerization technique, many properties have been greatly improved, such as the mechanical strength, the elasticity, the plasticity, the glass transition temperature, and also the surface properties of the polymer. So if necessary, the third monomer should be employed to improve the properties of polymer. That's why you study the copolymerization. So the mechanism of copolymerization is similar to that discussed for the polymerization of one reactant. We call it as a homopolymerization. But we can predict the amount of the monomer by study the polyfunctionalities. So, by the way, copolymerization is quite complex process than polymerization using a single monomer, because during the copolymerization we need two monomer at least, and the tendency of each type of the monomer to add to the growing chain in the propagation step may be different, right? So it is important to be able for you to predict how copolymer composition varies as a function of comonomer reactivity and concentration at any time. Why? In copolymerization, it only happens in a propagation step. Will depend only upon the last monomer in that chain. We shall concentrate only on the propagation step to produce copolymer. Reactivity of active site we assume to be determined solely by the nature of the terminal monomer residue which carries the active site. So copolymerization of monomer involve M1, which is monomer 1, and M2, at least monomer 2, will produce homopolymer alternate, ideal, or truly random. Okay, so for ideal copolymer, we call it as a random copolymer, and also non-ideal copolymer tendency to blockiness or alternating. For non-ideal, it will lead to produce block or alternate copolymer. The simple copolymer equation will be developed for the case of free radical reaction. So we have four possible propagation reaction which contain monomer 1 and monomer 2. So the K11 is rate constant propagation at monomer 1 and monomer 2, K12, K21, and also K22. It has its own rate constant. K is a rate constant or propagation rate constant. Actually, K1 means that it comes from the monomer 1 react with the monomer 1. For K12 came from monomer 1 with the radical react with monomer 2. So it produces K12, and same goes to other kinetic. All this propagation mechanism, it will have a tendency to produce several type of polymer. So we assume that for blocks or homopolymer, if K11 more than K12 and also K21 more than K22, it will lead to produce blocks and or homopolymer. For alternating copolymer, if K12 more than K11 and K21 more than K22. And for random copolymer, if K11 equal to K12 and K22 if equal to K21. Copolymer equation, the relative rate of incorporation of the two monomer into the copolymer at any instant is given by the instantaneous copolymerization equation, which obtained in this formula. So dm1 here is the mole ratio of monomer 1 and monomer 2 in a copolymer, and m here and m2 here is the mole ratio of m1 and m2 in a feedstock. And K is the monomer reactivity ratio. You just need to remember R1 equal to K11 over K12 and R2 equal to K22 over K21. You don't need to familiar, or you don't need to memorize this kinetic which is complicated. Just remember R1 and R2 formula. R1 and R2 is the monomer reactivity ratio. So this equation will give the composition of the copolymer being formed at any instant during the reaction. R1 is the ratio of the propagation rate constant for the addition of monomer 1 and addition of monomer 2 to a propagating radical chain with monomer 1 at the radical end monomer 1. So for R2, we have the ratio of the propagation rate constant for the addition of the monomer 2 and addition of the monomer 1. Okay, to a propagating radical chain with monomer 2 at the radical end of monomer 2 above. And the reactivity ratio can be classified into ideal copolymer, block copolymer, and alternating copolymer. Now we will look at the condition for the ideal copolymer. Okay, for R1, okay, I will explain in the next video.